Hi, welcome back. Today I'm going to do some of the couple of problems on transversals. Now, first, let's consider a simple problem, which is a combination of um, algebraic equations and also like application of transversal problems. Most of the problems in transversals are relatively straightforward if you understand the concepts. This is slightly tricky one, but I think I wanted to solve it. You can also put a request in comments if you feel that like there is a more complex problem that you want me to solve. Well, I will try to do that for you. All right. Um, Let us see, like I think what we have got here. It's always important that like you understand what is given and what is that like people are asking you to compute. There are three parallel lines given here. AB is one parallel line, CD is another, and EF is another parallel line. There is a transversal tree that cuts all the three parallel lines. And there is angle X and angle Y, both are on one side of the transversal, and there is angle Z that is given. Angle Z is on the other side, right? So they want us to find X. So from your past lessons, I think you know that like X and Y is equal to 180. Why? It's because these are on the same side of transversal and the co-interior angle sum will be 180 degrees. All right. Because y is also like on both sides, right? I think so. If you see, let's call this point as O. TOC, angle TOC and angle BOK, both are going to be the same because they're vertically opposite angle. And it need not be transversal. This can happen for any intersecting angles, right? I think when we studied vertically opposite angle, we realized that these both are same. Now, again, on the other side of the transversal, you see y plus z is equal to 180 degrees. Why? Because they are also on the same side of the transversal and they actually sum up to 180 degrees. Now, also like people have given that there is an equation y is to z is equal to 3 is to 7, which means y by z is equal to 3 by 7, which implies y by z is equal to 3 by 7, which means y is equal to 3z by 7. So now take the value of y from here and update here. What do you get? Y plus instead of z, what we are saying, so we can compute y, right? So you can come 3 by 7 z plus z is equal to 180 degrees. So it becomes 10 by 7 z is equal to 180 degrees. Z is equal to 7 by 10 of 180. That becomes 18 into 7. That is same as 126. Z is 126. What is y? We're going to compute that y is equal to 3 by 7 of Z. 18 3 is 54. 3 by 7 of 126, which comes 18 into 3, which is nothing but 54 degrees. If y is equal to 54 degrees, we're going to take the value of y and put it in x plus y is equal to 180. So y then x becomes 180 degrees minus y 180 minus 54 degrees, that is equal to 126 degrees. So we found the value of x by applying only one formula. But the trick here is to identify that these two are vertically opposite angle. Let's find one more problem. So given two parallel lines PQ, so and they have some kind of, they didn't say that it's a transversal. So if you actually see they intersect at a point M, there are two lines drawn. One part is X and other is M, and there is also Y. And from this point, I think there is another line drawn, and both of them intersect at a point M. Now, people are asking us to find this particular angle, right? So what is this particular angle is what is the question right now is. Now, this can be solved in multiple ways. In CBSE textbooks, you see like I think a little bit of higher order thinking is required to solve that in CBSE textbook solution that is given. But I'm trying to simplify it and see like I think how we can solve this particular problem. Extend from point M, extend this line XM to some point K. such that what happens? Xk becomes the transversal. Xk becomes transversal, right? So it's a natural extension of this. You could also extend ym directly to which intersect with PQ so that this becomes the transversal. But as of now, I think this is enough. So because what you call PQ is also a straight line, and this angle is already given that 135 degrees. What will be this angle? This angle will be 45 degrees. Why? Because of linear pair. As xk is a transversal, so this angle also becomes 45 degrees because alternate angle. So let's write that angle PXM is equal to angle MKY. Why? Because these are alternate angles, right? So because this is 45 degrees and this is 40 degrees, and we got one triangle here. All of you know that sum of all angles in a triangle is 180 degrees. So what will be this angle? What will be this angle? If this is 45, this is 40, it's 85. This angle probably will be how much? 95. Right? How come is that? 40 plus 45 plus x is equal to, let's say this is x, 180 degrees. X is equal to 180 minus 85. This becomes 95 degrees. If this is 95, what will be this angle? Because this is also a straight line, this angle will be 180 minus 95. This will be 85 degrees. Right. This solution, I find it a little bit easier compared to what is given in standard textbooks everywhere. But we'll also talk about how to solve the other problem as well. The same problem using a little bit more efficient thinking. But I feel that that particular thing is a one trick kind of thing. If you don't understand it, you'll not be able to, what you call, if you don't understand that particular concept, you'll not be able to draw a completely new parallel line and then try to relate with it. So let's solve it like how it is given in CBSE textbooks as well. So if you look at CBSE textbooks, they say that, hey, why don't you actually draw some line KL, let us call it KL that passes through M and which is parallel to PQ. Draw a line KL which is parallel to PQ and also parallel to RS. This is the only trick that you need. And if you don't recognize that there is an opportunity to actually draw a parallel line, you'll not be able to solve it. Again, it's the same problem. So this becomes 45 degrees because these two lines are parallel. This alternate angle becomes 45 degrees. Again, these two are parallel. And this is 40 degrees. This part becomes 40 degrees. So you just add like QML plus LMY is equal to, what is QML plus LMY? It is called angle QMY. That's what I think. So XM. That's what people ask us to find. So angle XMY is equal to 45 degrees plus 40 degrees is equal to 95 degrees, 85 degrees. So you can do in both of these methods. The answer is same. But here the trick is to identify and draw like some line which is exactly parallel to PQ and also RS. Here, I think we're not relying on parallel lines. We are relying on extending one of the line so that that becomes the transversal and applying a triangular properties to solve it. It all depends on how you want to solve and how you get equal marks in either case. So you don't really have to worry about it. Um, Thank you. If you really like my content, consider subscribing. Thanks a lot.